a smart Great Lake and a smart Lake Erie, trying to bring these concepts of distributed sensing, big data analytics, and advanced networking into the natural resource space. And here with us today, we have two real experts in the field. Sudhir has been working with us for some time and really shaping our approach from a technical perspective. And we're really excited here to be celebrating our recent memorandum of understanding with the South Korea water cluster here with Dr. Yum as well. So what we're going to go through here today is a brief overview from Dr. Kshirsagar on IoT and cloud computing for water technology. Then we'll hear in a little more depth from Dr. Yum on the work that's being done in South Korea, and then in a little more specific on the work that Hydrotrek is doing, and then we'll have some time for Q&A towards the end. So right now I'd like to hand it over to Sudhir to present a brief overview of IoT and cloud.
Hi, this is Sudhir Kshirsagar from Global Quality Corporation, and we have an Hydrotrek set of products that we have been building for last few years. But the focus of today's talk from my side initially for the overview would be to try and see if we can dispel some myths about how IoT can be used in water and how cloud computing can be used in water, and also to address some of the issues related to is it secure enough, and how best to leverage the new technologies that are available specifically in the water context. Again, through the MOU with Cleveland Water Alliance and the Smart Water Grid Research Group in Korea, this has been a great occasion to come together to share technologies, and as well towards the end in the Q&A, hopefully get some feedback and listen to some of your concerns and questions and suggestions that you may have as to how you see from your perspective how the IoT and cloud computing can make life easier in the water sector. So the first slide actually shows the different kind of areas that can get addressed through the application of IoT and cloud computing. There's a little picture of me as we participated in the HAB monitoring challenge in the lake, near Sandusky, where I put a nitrate sensor and used LoRaWAN to demonstrate that it is possible to use some of the new techniques to start addressing some traditional challenges. So the let's see if I can get to the next slide here.
Okay, I guess double clicking.
Double clicking, okay. All right. Okay, so the word smart often gets used in the context of all this, and I think we have to be careful how we use the word, because why are we being smart, just now, and were we not smart before? So I think the word needs to be interpreted more that we're going to improve our decision making through the use of this new IoT technologies and advanced analytics and other things that we use. And a good example from a related space is the driverless car. It's not that we weren't smart enough to drive our own cars. It's just that, the driverless car technology gives us additional things like perhaps reading a newspaper from the back seat while your driverless car is taking you to work. You're not worried about the traffic and less stress when you arrive at work. So, and then clearly over the last few years, quite a few dollars have gone through towards that, driven by the marketplace. Whereas in water, the absorption of new technologies, the catch-22 saying, is there a market, is there a technology, has been an issue. But nonetheless, we are seeing applications now of this new technology and new computing power in a variety of areas, and listed some variety areas here. So first area is the asset management. And in fact, from the Ohio-based utilities now, that may be a bad word, given some of the new regulations that have come down from Ohio EPA. We are required to develop an asset management plan quickly, so to speak. And then one knows that it's not that easy to manage assets. You know where they are, and because you're operating utilities, but documenting them and perhaps getting in the GIS and the whole workflow related to that, the whole process can be extremely complicated. Now, if you take the example of application of smart technologies in the asset management, for example, people have started using the RFID tags and some other tags. And a good example of a failed use case of a smart management assets in my mind is perhaps the smart bags, because the bags became smart, but the airline said, no, we can't get on the plane if you have a smart bag. So you have to be very careful how you absorb some of these smart technologies, just because it is cheap and inexpensive, but if it uses a lithium battery, you have to consider consequences. So you can take your entire water state of assets and you can put some smart things on it, but getting them provisioned, tagging the way they are, there is a amount of work to be done here. And then over time, how you manage that. So even the adoption of smart technology is not an easy process necessarily in all cases. Again, the revenue management, smarter applications that look at revenues, the water quality compliance, detecting events or detecting trends in your water quality signals before an event actually happens. A good example is Flint. Chlorine sensors are not that expensive compared to some of the other sensors, but we didn't have enough sensors in the distribution system that said, your chlorine residual is actually dropped to nothing. They didn't have even models to predict that based on this set of operation, you're going to have, very little chlorine residual in these parts of your distribution system. So perhaps, if the chlorine sensors were to cost, $50, and if the telemetry was only $1 per device per sensor, we wouldn't have, is the installation and maintenance still an issue? But clearly, given instead spending $128 million to fix the system later, you can, being smarter, you can fix some of the things. So again, the workforce efficiency, where do you dispatch something? Is there likely a main break or something that's going on? In the planning side, we still, traditionally used to taking your model off the shelf and doing that. And then the conservation side, in a non-revenue water, how do you account for it and kind of use some of the smarter technologies? And then so you have sensors, you have controls, you have communications, you have analytics, you have visualization, and all those areas you can actually think about how smart is going to help me. And so some of the technologies and the benefits are described in this slide, meaning there is a new generation of telemetry that can go over the long distance, the new chipsets that can talk to your existing sondes, they cost only $30, $40, and they can do both the data acquisition and transmission on the same chip. The data plans for this new kind of things are only down to $1 per device per month. And these are much more secure than our previous protocols. The opportunity of applying deep learning and computer vision, as you have more data from these sensors, that becomes, advantageous. And then clearly the use of smartphones and other apps for data collection, that makes life easier, and data entry, automatic data entry. And the last thing is actually wearable devices, which have been, touted for the regular consumer, using that in the workplace, in the water place. That's another interesting area that can do that. I'm just going to talk about, sensors are dime a dozen, literally. And these are not just, things that are non-reliable. Some of them are made by, Bosch and Honeywell, and they still cost $5, if you get air quality sensors. And then some of the things, newer sets of technologies, being rolled out nationwide. South Korea Telecom has rolled out LoRaWAN nationwide, and there's a rollout in U.S. AT&T and Verizon has rolled out the equivalent set of LTE Cat M1. Their towers are ready to go. And then the other thing is the protocols that you need to talk to the existing sensors with are pretty much standard, supported by this new chip. So you can keep your existing sensors on. All you do is throw your old data logger that's using the 3G modem and put this new technology on top, and good to go. And then the cloud computing also, it's very detailed and involved, but off the shelf, you're already using some of them like Office 365. So you're already using some of your data already resides in the cloud, and so how to leverage that in a secure manner is also went to this. So now, before we get into the details around how some of this technology is used in the hydrogen product, we're going to switch gears a little bit and let Dr. Yeong talk about how, for example, South Korea, which has always been a leader in technologies and applications, doing some of this work. So Max is going to help us get
going to start with a video. Okay, we're going to start really quickly with a video that just kind of frames some of the work in the smart water sector. We're doing this in a little bit of a hacked way, playing it through the computer into the microphone. So if the audio isn't so good, we're definitely going to share this video later, but the visuals themselves I think will be quite helpful. So I'm just going to play this real quick.
Enriches our lives. It's something we simply can't do without. What would happen to us if we ran out of water? Due to weather changes in the past years, the amount of water we have access to is being depleted in our reservoirs and rivers. It is time that we put in the effort to save our precious water. Wouldn't it be great if there was a smart water management system? The water we filter and use at the moment is sourced from rivers and bodies of water. As such, we may at times experience a shortage of water, which will require sourcing the water from elsewhere, increasing the costs. If we can utilize different sources of water in each region and use only what we need, our water supplies will become more independently efficient. We will need to treat different water sources with different methods. We could then distribute the treated water accordingly. By streamlining the process, costs will be lowered and energy will be saved. If it is difficult to secure alternative sources of water in a region, we may be able to sufficiently draw from nearby regions to alleviate the problem. Emergencies such as droughts can also be handled through this flexible, interconnected structure. Once this system becomes operational, we will be able to measure and quantify our water usage, as well as responding immediately to emergencies. If we install smart meters in every home to measure real-time usage, our water management will become even more efficient. You will be able to receive real-time data on water usage through a mobile application through your Wi-Fi network. Add an integrated master control center to facilitate all of this effectively, and you've got the whole package. All of this is possible and very much needed for our next generation. Intelligent water management system. Save water, save tomorrow. Smart water grid.
Just going to switch over to Dr. Yeong's PowerPoint really quickly. All right, now here's Dr. Yeong.
Yes, good morning. I am Yeong-jong, professor Sungkyunkwan University, and I'm also director of National Smart Water Grid Research Groups Korea as well. I'm very glad to be here, and I am very happy to introduce what we have done so far by our research groups. Today's my topic is smart water application in Korea, history and status. After giving as my presentation table, after giving a brief introduction of the Korea water resources, I will introduce about the smart water application in Korea and its history. And finally, I will introduce its status.
Sorry, I think we lost network connection really briefly. Give us one moment. So I'm hearing that we can't see the presentation. It looks like we're connected now. Oops. Emily, are you on the line? Can you see the presentation now?
I am on the line now. What we're seeing is the last frame of the video.
Oh, the last frame of the video? Okay, I'll close that. Maybe it's taking precedence for some reason. Is that fixed?
No, you know what I'm going to do? I think I'll remove your presenter control, and then I'll give it to you again, and you can share your screen again.
Okay, that's fine. The previous slide? Okay. Yeah, we're working right now. People on the other end aren't seeing our slides for some reason, so Emily's going to remove our... Emily, should I try again now? Ooh, connection restored. Cool. Screen share. It's up now?
Yep, it's up now.
Awesome. Sorry about that, Dr. Yeong. Please.
Yes. As my contents, after giving a brief introduction of the Korea water resources, I will introduce smart water application in Korea and its history. And finally, I will introduce its status. First of all, I would like to start with introduction water status in Korea for your better understanding of the history of smart water technology in Korea. As you see on this slide, as of 2015, the total population was almost 52 million, and GDP was 27,000 US dollar. As you can see, the urbanization rate, Waterworks service rate, and housing rates are very high, almost near 100%. Korea has total water resources over the 127 billion cubic meter per year, but out of them, only 26% has been utilized due to a special and temporal reason. And then the LPCD is almost 290 liter per capita, and the water services ratio is almost 100%. In the case of the sewage service rate is also very high, almost 100%. This slide shows very well on how the climate change have changed the pattern of rainfall, then in flow, in temporal, and spatial. This means we need to come up with solutions against uncertainties and irregularity of water inflow. So it was the one reason to launch the National Smart Water Grid Research Group by a Korean ministry in 2012. So what we need smart water. You know, in coming decade, there is strong chance of having water scarcity and in the water stress due to imbalances between water supply and demand. This led us to something to secure water in many ways. This slide shows the drought map of from November 2015 and July 2017 of Korea Peninsula, which shows the repeated extreme droughts. We have suffered from 5 years continuing drought. As you can see this figure, even the ratio of the non-living water is very low, but we are still eager to save non-living water to secure water. Because of the severe drought across the country, recently we are doing very special project connecting rivers and different watersheds to overcome these droughts, never seen before. There is no exception even on island, where mainly depends on limited groundwater. There are about 100 relatively big islands, and in case of no rain, no way to except to bring fresh water from a mainland by ship or desalinated water, which costly and complicate to purify it by residents themselves. More actively come up with water problems and to promote the water industry, Korea has been developing water industry cluster in Daegu. There is also a local Waterworks modernization project with 3,000 billion won. It means that the 30 billion US dollar cost starting from 2017 last year and will end in 2028. This project mainly focused on to build block system to save non-living water, energy, and a remote billing system by introducing AMI system. Another big trend in water industry in Korea is Smart Water City project. As one of the symbolic pilot projects, Dae-cheong Smart Water City project is running from 2017 to 2020 with a total business expenses about the 12 million US dollar. In line with these water policies, the National Smart Water Grid Research Group was established in the 2012. The National Smart Water Grid Research Group is running since 2012. You know, the Smart Water Grid has a short history and then initiated in the 2009. Hence, it seems Korea started in the 2012. That means Korea is one of the early adopters in the field of smart water grid technology. Now I would like to talk about key research works, what we have done so far by our research groups. The key research works, first one is the diversifying technology for multi-water sources to secure water, and second one is the real-time smart monitoring and controlling of water networks by using AMI system, and the third one is that the app-based bilateral communication with various types of applications between a supplier and a customer. The first is that the diversification of the water sources. The key concept is how to use combined multi-sources that are available nearby, like seawater, spring water, surface water, groundwater, etc. Therefore, it is very important to consider quantity, quality, cost, and the sustainability of especially groundwater. We decide Dae-cheong Island as a test bed to demonstrate a smart hybrid water producing system with a capacity of 100 cubic meter per day for 125 households. The place is located very far from mainland, and it takes about 5 hours by ferry just under North Korea. It is on unmanned, controlled, and movable systems to another island. And there are multi-sources. You know, they have the 3 multi-sources: underground water, brackish water, and the seawater. multi-sources will be used according to priority, like as when the groundwater lows down due to lack of rain, then it starts to reduce the use of groundwater to protect the ground aquifer systems. And then next, brackish water or seawater will be substituted by the same amount of reduced groundwater to meet the demand. So-called blending process are starting. The cost is dependent on blending ratio among different sources. Now we are preparing guidelines for optimal blending ratio among different sources and program estimating available water intake. Anyway, the concept of utilizing nearby multi-sources would be very recommended because it can increase resilience against vulnerability and also will be cost effective as well. This slide shows a schematic diagram ranging from sources to consumers about the multi-sources. And the next one is in the technology, decreasing non-living water by means of pressure management by using AMI. AMI means that the advanced measuring infrastructure. When you say smart water management, as Mr. Sudhir told already, AMI system plays a key role in terms of gathering real-time data and system monitoring and decision making. So we developed ultrasonic wave-based water meter AMI network device, which can reduce electricity cost, improves measuring precision 50 to 200%. Yeong-jong Island, where international airport is located, was selected as a testbed to implement a smart water grid technology with about 530 AMI units, including integrated operation platform. It covers an area of about 18 square kilometers. You know, the airport new city and population is about 17,000. This smart water grid system built in Yeong-jong Island is being operated to prove and customize three main targets. First one is that the providing demand-based water supply system in real time, including pump scheduling related to prioritizing use of multi-sources. Second one is to decrease non-living water by monitoring and analysis of water pressure in the network. And third one is to develop a remote billing system to save labor cost. So far, the result of the operation seems to be very satisfactory. The real-time data acquisition rate ratio through AMI system in test bed are almost perfect. Almost, you know, the 99% per hour. And this slide shows the pattern of water use in various purposes from big data transmitted in real time. Based on this pattern, we can make a plan of water supply, including pump scheduling and source combination. As I mentioned already, there are many, you know, the multi-sources available to use. This slide shows that now we are simulating the water distribution network analysis by applying EPANet engine based on real-time flow data over customers using AMI. Approach method for analysis with AMI is to find water consumption pattern by hourly, daily, weekly, and seasonally what we want to set up water supply plan. In the event of the abnormal status and leakage in the pipe, the closing valves and cutting up the customers can be searched for efficient network management through an alarms to customers. And by means of through the bilateral communication with the final consumers and the suppliers, as I mentioned already. This slide shows that the procedures for searching involve selecting the abnormal status of a leak, searching the valves to be closed, and searching the cutting of the customers by closing valves. This technology is developed by deep learning, the method, etc. And also we have studied economic benefit analysis of a smart water grid, the demo plant. So we can confirm the necessity of smart water grid technology, and it should be included in conventional waterworks as soon as possible to save the energy and in the water, and to enhance the sustainability, especially in the groundwater, to protect. Next one is the bilateral communication with consumers. I think this part is very important. We built integrated monitoring and controlling center in the Incheon metropolitan city. Dae-cheong and Yeong-jong plants are being monitored and controlled by remote in real time. We have developed 3 types of water applications. First one is the water diary, water care, water community. Through bilateral communication with this application, the table credibility is raised, and then the rate of drinking tap water directly increased from 7% to 46% in Paju City, whereas the average usage of tap water in national scale is very low, about the 5%. Consumers are able to know water-related information regarding the water flows from the sources to tap that are monitored in real time through a sensor, ICT, etc. Next one is that the international cooperation with smart water grid research groups and then the other countries. So we have been actively cooperating with other countries. For example, with Vietnam, Jordan, Indonesia, and Thailand, etc. We have the complete the smart water the technology. I mean that the feasibility study in Jordan Karak area in 2016, 2 years ago. Now we are working on a master plan for northern part of Jordan to apply a smart water grid technology. So far, we have signed U.S. and with many national smart water grid research groups from South Korea are ready to collaborate with the Cleveland Water Alliance. Thank you very much for your attention. Thank you.
Thank you very much, Dr. Young. Now, before we switch over to a little bit of discussion and question and answer, we're going to have a presentation from Sudhir on some of the innovation going on in smart water here in the United States. I'm going to switch over the slides really quickly.
So switching back to some experience in using some of the technologies, We'll go through the product set that has been developed as part of the Hydrotrek line, and then the product set consists of both additional hardware that couples with the sensors to use this acquisition of the sensors instead of the existing data loggers, and the same data loggers are able to communicate with the new advanced telemetry back into your data stores to retrieve the data. And then the data that comes in either through the existing systems and supplemented by this new data acquisition can be then used in very interesting ways to do some smart modeling. A good example is in water distribution systems. For example, if you have the flow rates out of your pumping stations and then you also have level transducers on your tanks, then you can translate the tank level fluctuations into the demands of the tank. And there is some advanced analytics that gets applied before we can easily convert the tank demand fluctuations into demands, because the tank levels are noisy. And so you can apply some very interesting mathematical techniques to get the smooth demands from the tanks. So once you have that, then it's simple arithmetic to know how much water is being consumed, both the non-revenue water as well as the actual demand that's going into the system. And the way you use that information is if you actually can separate that kind of process into separate zones or in the entire system, then you can actually fine-tune the demands that you were used when you did your planning model to change that to reflect what's really happening in an operational sense in the system. And then that operational sense of the system is really gives you a different picture than what the planning model gives you. And that's important for a variety of reasons, because if you wanted to see the real flow path as to where this water introduced from this source is going to next, then only the smart model can tell you that. Your planning model would probably most likely give you a wrong answer. If you also have a pipe main break, there's some new requirements coming in that you have to actually let the regulatory agency know how much pressure was there when the main break happened. And it's obviously impossible in that situation to go around carrying pressure transducers. So you're going to measure the pressure. So one of the suggestions from the water utility was, can we actually give you an estimated water pressure? A good example would be the use of the real-time model to then actually give fairly accurate values. And some of the new advances that have taken place in the fundamental technologies that have been developed in the United States, mainly the EPNet, and even Dr. Yum uses EPNet. We have to be really proud of that. And then also the swim model that gets in the stormwater. There are new advances in EPNet where when a break happens, the pressure-driven demand, that's now handled better in the new version of the EPNet. And then the smarts can be combined with that to do that. And then the same thing is, once you have a smart enough model, you can do a different what-if scenarios to look at the pump energy and optimization of that. So these are some examples of, on the water side, the use of that. On the collection systems, instead of continually calibrating separately the sewer model, you can actually connect that sewer system data, given that now flow monitoring through some of the smart newer technologies has becoming more common. You can start looking at the data from the SCADA system. In this case, in the collection system, that line is shown in blue, and then the red line is the model, what it's saying and predicting, meaning the Doppler images show that the rainstorm is coming in and your manhole levels are going to go up. And then in terms that, looking at some of that to improve the optimization of your underground assets to reduce the combined sewer overflows. The stormwater calculator is another example where the cloud really comes in handy, because you get the soil conductivity, the slope, variety of things directly over the internet without coming to your desktop. and you click a button that says, please tell me what the runoff is, and it runs the US EPA standard engine and gives you an estimate the runoff. And then you can also put the low impact development LID controls and say, if I were to put 10% of the area and put rain barrels there, how much would I get a reduction in runoff? And that gives you a very quantitative way of implementing some of your LID controls versus, best guess saying this is going to work for it. Or if you have an intuitive approach towards that, this helps validate saying, oh, I think you guys made the best decision in promoting this type of BMP. And then the last thing is related to the use of phones and smartphones. And in this case, you can point it towards, a storm drain and see, what's the flow coming out of it, if it's really, overflowing, or how much flow going into it. Getting more quantitative so that as we try to improve our stormwater management techniques, we have more quantitative data. And this is an example and details of that same sewer system, a storm coming in, and you got measured data and predicted data. And then similarly for, if you want to predict river quality for recreation, you can use neural networks based on training them with some previously available data, and then you can have better estimates of after a large rain event, how likely based on some of the CS and other things, you're going to have your E. coli concentration. The river spill modeling in a smart sense actually being done in the Ohio River, 1,000 miles. And there it's very important to have very accurate numerical calculations going on because water utilities have very little reserve, so that they can't really shut off their intake for 2 days. So when is the plume going to arrive? When it's going to leave? Very important to know. And then as well as there is also a sensor network on the Ohio River, which is getting upgraded so that you can have more accurate values for the variety of spills that happen either through barge or loading or what have you. And then in the lakes, a good example is similar to the challenge that was run by the Cleveland Water Association for the Lake Erie Hackathon. Clearly, several teams demonstrated that it's possible to use a variety of different sensors, effectively use this new technology. It's not just on paper, it's being used in Europe, and with a solid implementations that actually had actual data coming in so that we can look at a variety of concentrations of nutrients. Again, the master planning is one thing, but fire flow leaks, how do we use some of the smart technology to do that? And then again, smart modeling, what is it? And in a variety of different ways, you adjust side by side, modify the model, a tremendous set of opportunities in which way the new data can be used to improve what you're doing already, perhaps, and not necessarily with a significant cost investment. And then the key thing is the results have to be, need to be easily absorbed by the operators. And so the user interface and other things have to be very carefully designed so that it looks like just a SCADA system versus looking at running a very complicated model. And we talked about, as we details of some of the preparation, does get into actually improving your core data sets as you get into some of the smart efforts. You find some additional interesting things about what you are using for planning and operations people, and then actually some improvements come as a side effect of getting towards the smart thing. Again, different ways you can use the smart modeling to look at the previous history, what's going on now, and in the forecasting side. And an example of event detection, EPA spent $10 million about 10 years ago, and the same thing now can be done very easily, on a handheld unit, on the unit the size of a palm. And then, although there is some complications in terms of how do we have the network, luckily the network vendors have stepped up and starting to offer you improved security as well as connectivity for this new generation of telemetry. And so an example of cloud computing, can do a variety of different ways, truly running in the cloud, an example where this was implemented, the swim model, and this is more an advanced stage because some of the other ones are not that level yet. So as an overview, variety of techniques can be used for doing that. And then rest of it is just some examples of slides that show, some of the details behind what was already described. So I'm going to go into too much details on each one of the slides. These were kind of discussed. But the last piece I want to talk about is really the impact on workforce. That has to be carefully looked at because it's not that you're just going to, have layoffs. So you may have layoffs somewhere, but you may have some increased hiring. You may retrain some people. So the absorption of smart technology can be done very carefully. And then, and this is just more about the Lake Erie Hackathon where, variety of technologies were used. And if someone's interested in details as to what kind of technologies guys use and how they play in, that's an example of the little event detection, which now runs on, Raspberry Pi. And again, the solid architecture of the networking takes some thinking behind to get the security in. And, so it's not to throw lots of technologies. This is simply to say that there are technology choices and you can make your choice, pick the thing that best works for you. And, that's pretty much the long and short of it. And you can use it for a variety of different things. So that's the last piece. And we're down to the Q&A session.
Thanks so much, Sudhir. Thanks to both of you for sharing your insights. This is really fascinating, a fascinating session. From Dr. Yeong, I learned a lot about, kind of the work that Korea is doing to blend diverse sources of water to meet the demand sustainably in a world where things are increasingly unpredictable, understanding consumption better, reducing non-revenue water and those sorts of things. I guess what I'm curious about is kind of what's next in terms of South Korean innovation in smart water. What are the fronts that you're really pushing forward, the things that you see coming down the pipeline?
Okay, thank you very much. What we are doing in nowadays, and then the next, our plan is that the first one is what we are doing now is that the on-site experiment to develop real-time decision support systems. I mean that the customizing this DSS model, that means that that can provide optimal combination of available multi-sources. They are considering economy and sustainability and resilience for the vulnerability. So customizing is very important. As I mentioned already, we have implement our research works within two phases. First phase, and then now we are doing in a second phase. So in nowadays we are trying to customizing decision support systems. And second one is the pattern analysis on big amount of the water use data, which is the transmitted in real time from AMI network with the 530 smart meters we spent. And then installed in the test bed in the Yeong-jong Island, the international Incheon International the airport, where the almost 17,000 residents are living in there, and the big data. There are lots of data, so we need to find out some patterns, as I mentioned already. To make a plan, a demand-based water supply, then we should find out some patterns from the big data. So we are now doing that kind of things in nowadays. And then third one is the upgrading and the advancement of smart water grids operation and maintenance technology, so as to save energy and also to decrease non-living water and to increase efficiency and the technical stability with remote billing systems. So we introduce the smart the remote billing systems. We can save the labor cost, and then we can increase the accuracy the use
Right.
amount of water, etc.
Cool. Thank you. That's very interesting. Especially interesting. I think it segues well into kind of what Sudhir sees coming down the pipeline, the big data piece, and how we're leveraging and integrating big data. Sudhir, I know that a lot of the stuff that Hydrotrek is doing to push the envelope is in terms of being able to integrate diverse data streams from lots of different kinds of sensors. What do you really see as kind of the future angles there, and what's new and innovative in that space?
So I think the vision is for what I call a smart water platform to come together for the universal acceptance and good through a variety of collaborations between vendors and utilities and groups such as yours who will catalyze the process while working on solving specific problems that the utilities face today and bring those together in the smart water platform.
Absolutely. That's awesome. Well, we have time, I think, for one more question that I think, each of you will have an interesting perspective on. It's really exciting to be able to bring together these two perspectives, the U.S. perspective, the Korean perspective, on smart water in the same room here today. I'm wondering from each of you, what kind of value do you see in these sorts of exchanges? Those of us that are working across the globe in the smart water space, what can we learn from each other, and what does kind of bridging these national gaps contribute to the conversation?
That's why the reason why I came here, because we need to collaborate more than now. I think that in nowadays we are trying to expand the collaboration with other countries, so like as I mentioned already, the Jordan, Indonesia, and Vietnam, and some Thailand, as many countries has now being suffered with some problems. Not only the non-living water, but also with some lack of the waters. So that's why we need to spread out this kind of technology. So the United States, especially in the Cleveland Water Alliance, has many potential to develop this kind of technology. So that's why I came here to combine and then seek what kind of the collaboration would be better. So based on this kind of the collaboration works, I need to provide some test bed. So in Korea, I mentioned already, we are the build.
Yeah, you have a beautiful test bed.
Yeong-jong and then the Dae-cheong island already. So I really hope to build some kind of a test bed in here, and then to exchange some technical and some the core research works in terms of the sensor and meter, and then the detecting the non-living water, etc. So I think there are many things to collaborate between the USA and then the Korea smart water grid research groups, including some Korean teams groups. There are many the groups and the organizations hoping to work together with our
absolutely
the research group and then the USA also.
Yeah, excellent.
I'm going to keep my answer short. I think we buy a lot of Samsung phones. I think it's time we start selling them our US-built technology product. Apart from giving them the free EPNet, which they appreciate, I think they'll also appreciate if at a reasonable cost we provide them better solutions, which they would take others spend a lot more money to build. It's about the value proposition. That's what the global collaboration is all about. Sharing of ideas, and then the second piece of new research ideas through Cleveland Water Alliance, just the research that they bring to the table. So commercializing our existing technologies, both the hardware and software, greater adoption to solve specific problems at reasonable costs, because I know utilities have low budgets, and it's about improving the quality of life, and then be learning about new ideas, new techniques, and things that we can jointly contribute our smart thinking about. So,
thank you, and thank you both very much for sharing your time with us here today. For those of you on the line, if you're interested in continuing the conversation moving forward, feel free to reach out to us at clevelandwateralliance.org and to engage with our partners at SplashLink. If you're going to conferences, you can find us at ACE, on the water tech side, on the research side, IAGLR this summer, and then we'll of course be at West Tech and the One Water Summit as well. So we hope to continue this conversation with you in person as well. With that, Emily, I'd like to hand it over to you to wrap things up.
Thanks so much, Mike. And I'd like to echo your gratitude to our presenters today. It was really just a smorgasbord of interesting information today. I encourage you to also find us at ACE. We'll be there with Cleveland Water Alliance, I believe, actually. So follow SplashLink on all your social media channels. Look out for our next webinar in our webinar series. I hope you enjoyed that presentation as much as I did, and have a great rest of your day.
Thank you. Thank you.
Thank you.
Thank you.
Bye all.
Great.